Welcome to Tungal online classes. Today we are going to start the new topic, that is electromagnetic waves. It is a very small topic. From this topic a 2 marks question will be coming, right? Now, before going to discuss about the electromagnetic waves concept, first we will define what is the wave. What is the wave? So already we studied about the wave motion topic in the first PUC, about the wave motion topic in the first PUC. So there you define the wave is, a wave is nothing but the disturbance which is created in a given medium, the disturbance which is created in a given medium and which will be carrying the energy and the momentum from one point to the another point or from one place to the another place. So that is the main purpose of the producing the disturbance in the given medium, or that is the main purpose of the consideration of the waves. So what is the main purpose of the consideration of the waves means what? To carrying the energy and the momentum, to send the energy and the momentum from one place to the another place, we are producing the required wave. So how can we define the wave here? Wave is nothing but a disturbance. A wave is nothing but what? Disturbance produced in a given medium. The disturbance produced in a given medium is calling as a wave. And already we are saying that what is the main purpose for the consideration of the required wave means what? To send the energy and momentum, from one place to the another place. To send the energy and momentum from one place to the another place, we consider the required wave. So in the case of the wave motion, we told two types of waves are there. Those are calling as a mechanical wave as well as the non-mechanical wave. So what are the types of the mechanical waves? We consider there mechanical waves. The first one is what? Longitudinal waves. The first one is what? Longitudinal waves. And the second one what we consider here? Transverse wave. So already we discussed in the concept of the wave motion. The waves are mainly classified into two different categories. Those are calling as a what? Longitudinal wave as well as the transverse wave. So in the case of the longitudinal wave, what will be happens means whenever the wave is propagating, the particles which are present in the given medium will be disturbed. Whatever the wave you consider, either it is a longitudinal wave or electromagnetic wave or transverse wave or sound wave, whatever the wave you consider, whenever a particular wave is transmitting through a given medium, it is produces a disturbance in the given medium. As a result, whatever the particles are present in the given medium, they will be oscillate. So wave is also we are calling as the oscillations of a particle. The oscillations of a particle in a given medium will be representing the propagation of the given wave. So that when you consider the longitudinal wave, the particles are vibrating. Parallel to the direction of the propagation of the wave. So whenever you consider the type of wave is longitudinal wave, in that case the particle will be oscillates. How the particle will be oscillating? The particles are oscillating along the propagation of the given wave. Suppose if you consider the transverse wave, in the case of the transverse wave, the particles are vibrating perpendicular to the direction of the propagation of the wave. So from all these what we concluded means, you consider a given wave. Whenever you consider a given wave, 2 points we have to remember. The main purpose of the consideration of the wave is to carrying the energy and the momentum, So that is the first property of any one of the wave. And whenever you consider the wave, in that wave, what we observe the oscillations of the particle or vibrations of the particle. If it is calling as the longitudinal wave, in that case the particles are vibrating parallel to the direction of the propagation of the wave, as well as in the case of the transverse wave, the particles will be vibrating perpendicular to the direction of the propagation of the wave. So here we told these waves are which type of waves? Mechanical waves. So what is the meaning of the mechanical waves? The waves are produced by mechanically. The waves which are produced by mechanically means the sound waves will be traveling from one place to the another place. So what is the source of the sound waves? Myself or the speaker, whatever it may be. So here the production of the mechanical waves is required a particular source. Similarly, when you talk about the electromagnetic waves also, it is also requiring a definite source. Without any source, we can't produce either mechanical waves or electromagnetic waves. So, for producing any type of waves, what you required means a source of the wave is required. If you consider the mechanical wave, so for the mechanical wave one definite source will be there. For the sound, ourselves or speakers are the source of the sound waves. If you consider the water ripples, when we throw a stone into the water lake, so they will be producing the ripples over the water. So one source is needed to produce any type of the waves. So here we are discussing about what? Electromagnetic waves. For the electromagnetic waves, who are the source of the electromagnetic wave means the source of the electromagnetic wave is time varying electric field as well as time varying magnetic field. So how the electromagnetic waves are produced? So before going to discuss the properties of the electromagnetic waves, we have to know how these waves are produced. So the source of the electromagnetic waves are whom? The time varying electric field as well as the time varying magnetic field. So if these are time varying electric field as well as the time varying magnetic field are combined together, so they will be producing the electromagnetic wave. So that here, who are the source of the electromagnetic wave means the source of the electromagnetic wave is nothing but the time varying electric field as well as the time varying magnetic field. So this is the introduction of what? Waves. Here we are saying that the electromagnetic waves are produced by the combination of time varying electric field as well as the time varying magnetic field. So who was invented the existence of the electromagnetic waves means the scientist James Maxwell. The scientist James Maxwell was first identified the existence of the electromagnetic waves. He just gave the theoretical assumptions. He just gave what? Theoretical information for the existence of the electromagnetic waves. Once again, who invented the existence of the electromagnetic waves earlier means the scientist James Maxwell. He invented the existence of the electromagnetic waves in the space or in the nature. So by the theoretical assumptions. So to say that the electromagnetic waves are existing in the nature, so he collected some of the equations which are taken from the electrodynamics. So he collected a set of the equations. He collected what? A set of equations from the electrodynamics. So what is the meaning of electrodynamics? It is the combination of electric field as well as the magnetic field. Already we studied electrostatic, moving charges and magnetism, EMI, AC. All these are topics we are calling as a what? Electrodynamics. So for saying that the electromagnetic waves are existed by theoretically, what he did means he collected some set of equations, which are collected from the electrodynamics, So, such a type of equations we are calling as, Maxwell's equations. So, what are the Maxwell's equations? The Maxwell's equations are the set of the equations which are collected from the electrodynamics. Such a type of equations we are calling as what? Maxwell's equations. What is consisted by the Maxwell's equation means? These Maxwell's equations are consisting of electric field. These Maxwell's equations are consisting of what? Electric field as well as the magnetic field, and it is also consisting of source of fields. What are the source of the field? What is the source of the electric field? Charge. What is the source of the magnetic field? Electric current or current density. So that the Maxwell's equations are consisting of electric field as well as a magnetic field, that is source of the electric field, that is electric charge as well as current density, so that to explain the existence of the electromagnetic waves, what he was did means he collected some set of equations which are taken from the electrodynamics. Electrodynamics is nothing but combination of the electricity and magnetism. So those equations are named as what? Maxwell's equations. So what is consisted by the Maxwell's equations means? The Maxwell's equations are consisting of electric field as well as a magnetic field and their sources, that is electrical charge as well as the current density. So these are consisted by the whatever the set of equations was collected from the electrodynamics by the Maxwell. Now, whenever we studied the properties of the electromagnetic waves, so these electromagnetic waves are traveling with a speed of 3 into 10 power 8 meter per second. Whenever we studied, we analyze the properties of the whatever the electromagnetic waves are existed by the combination of time varying electric field as well as the time varying magnetic field. These electromagnetic waves are traveling with a speed of 3 into 10 power 8 meter per second. Already I told, whatever the waves we consider, they will be in the motion and they will be carrying the energy as well as a momentum from one place to the another place, so that these electromagnetic waves also carrying the information from one place to the another place with a speed of 3 into 10 power 8. What is the 3 into 10 power 8 meter per second? Which is indicating the speed of the light. So that from these observations, they concluded that from this observation, what is the observation? The speed of the electromagnetic waves will be nearly equal to the speed of the light. From this observation, they confirmed that the light is also a part of the electromagnetic waves. Why? The light as well as the electromagnetic wave both are traveling with the same speed. So that they confirmed that light is also the part of the electromagnetic waves, which is taken from the properties of the electromagnetic waves. All these are the theoretical assumptions only. Which was made by the Maxwells. So after him, in 1885, the scientist Hertz came. So already we heard about the scientist of the Hertz who was invented the photoelectric effect first. So Hertz will be explain the concept of what? Photoelectric effect. The same scientist Hertz in 1885 studied whatever the information was given by the Maxwell's and Maxwell's equations and their properties. Then he gave the demonstration of the existence of the electromagnetic waves in the laboratory. So that who was invented the existence of the electromagnetic waves by practically means he is nothing but the scientist Hertz. In 1885 he gave the demonstration in the laboratory and he proved that electromagnetic waves are existed practically. Electromagnetic waves are existed practically. That was given by the scientist Hertz. After him, another scientist is came, that is a Marconi. So Maxwell's is given what? Maxwell's is given only theoretical information about the existence of the electromagnetic waves. After that, the scientist Hertz was proved that the electromagnetic waves are existed in the nature. So by take whatever the information shared by the Maxwell as well as the Hertz, so Marconi was sent the information from one place to the another place with the help of the electromagnetic waves. So the scientist who was sent the information from one place to the another place with the help of the electromagnetic waves means he is nothing but the scientist Marconi. So this is the introduction part of the electromagnetic waves. Next concept is the very important concept, Maxwell's equations. Maxwell's equation. Already we told what are the Maxwell's equation. So he taken some set of the equations from the electrodynamics to explain the existence of the electromagnetic waves by theoretically. Those equations we are calling as a what? Maxwell's equations. In that the first Maxwell's equation is given by Gauss law in electrostatics. Gauss law in electrostatics. Already we told to explain the existence of the electromagnetic waves, he collected some set of the equations from the electrodynamics. That means already these equations are existed in the electricity as well as the magnetism. Such type of equations he collected together and with the help of those set of the equations he explained what? Existence of the electromagnetic waves. Now what is the first Maxwell's equation what he was collected from the electrodynamics is nothing but Gauss law in the electrostatics. Already we know that the Gauss law in the electrostatic equation is given by surface integral E bar dot ds bar is equal to Q enclosed or Q net by epsilon naught. Q net or Q enclosed by epsilon naught. What is the statement of the Gauss law? Already we know that according to the Gauss law in the electrostatics we will say that the total electric flux which is passing through any closed surface, total electric flux which is passing through any closed surface is equal to 1 by epsilon naught times to the net charge enclosed by the closed surface. Net charge enclosed by the closed surface. So that the right side term will be giving what? The right side term will be giving what? The net charge present, the net charge present in a given closed surface. So in the Maxwell's equation 1, the right side term will be giving what? The net charge which was present within the given closed surface. On the left side term, surface integral E bar dot ds bar is giving what? The total flux or the net flux passing through the closed surface. So according to the Maxwell's first equation, he relates the two physical quantities. What are the two physical quantities? The net flux which is passing through a given closed surface depends upon the physical quantity of the net charge which was present in the same closed surface. So according to the Maxwell's first equation, he explained about the two physical quantities, that is nothing but net charge which was present within the closed surface as well as the net flux which is passing through the same closed surface. So this is about what? First Maxwell's equations. So the first Maxwell's equation will be giving the existence of, it is giving what? Existence of isolated electrical charges. So it is giving what? The first Maxwell's equation will be explaining about what means. It is explaining the existence of the isolated charges. What are the isolated charges? A charge which is separated from the given system. So if you consider any one of the positive charge, any one of the positive isolated charge, from this positive isolated charge, the electrical field lines will be moving outwards. If you consider the negative charge, the field lines are entered into that given negative charge. So this was explained by the first Maxwell's equation, that is nothing but Gauss law in electrostatics. Now, coming to the second Maxwell's equations. What is the second Maxwell's equation here taken from the electrodynamics means? That is nothing but Gauss law in magnetism. Gauss law in what? Magnetism. So what is the Gauss law in the electrostatics? Surface integral E bar dot ds bar is equal to Q enclosed by epsilon naught. So what is the equation that is for Gauss law in the magnetism is surface integral B bar dot ds bar is equal to 0. Surface integral B bar dot ds bar is equal to what? 0. So what was explained by the Gauss law in the magnetism? If you take any one of the closed surface, in the given magnetic field region, the net magnetic flux passing through any closed surface is equal to 0. So what was giving by the Gauss law in the magnetism? According to the Gauss law in the magnetism, we will say that the net magnetic flux passing through any closed surface is equal to 0. So what is the meaning of net flux passing through any closed surface is equal to 0 means if you take any one of the closed surface, the number of lines of forces are entered into that closed surface is equal to the number of lines of forces leaving from the same closed surface. What is the meaning of the net flux is equal to 0? If you consider any one of the closed surface in the given magnetic field, so it is saying that the right side term will be is equal to 0 means what? The total number of magnetic field lines of forces are entered into the closed surface is equal to the number of field lines are leaving from the same closed surface. Hence, we will say that the net flux passing through the given closed surface is equal to what? 0. Given closed surface is equal to what? 0. And one more point will be given by the Gauss law in the magnetism means whatever the lines of force are existed in the case of the magnetism, these lines of forces are the closed loops. In the case of the electrostatics, the electric field lines are not the closed loops. But in the case of the magnetism, whatever the magnetic field lines you consider, these magnetic field lines are the closed loops. Because of that only, the net magnetic flux which is passing through any closed surface is equal to what? 0. And so in the case of the first Maxwell's equation, it was given the existence of the isolated charges. So it explains that there is no existence of the monopole in the case of the magnetism. The Gauss law in the magnetism is saying what? According to the Gauss law in the magnetism, it will be saying that there is no monomagnetic pole will be existed. If you cut any one of the bar magnet into small number of pieces, each and every piece will be acting as a dipole. We can't get monopole in the case of the magnetism, which was explained by the Gauss law in the magnetism. This is what second Maxwell's equation. Maxwell's equation is nothing but Faraday's law. So this Faraday's law already we studied. In which topic we studied? Electromagnetic induction. So according to the Faraday law of electromagnetic induction, there we studied what? The induced EMF is equal to the rate of change of a magnetic flux. E is equal to, we studied, minus d phi by dt. So this equation is saying what? Whenever there is a change in a magnetic flux will be there. This change in flux is due to what? The change in a flux what we consider there, that is due to the change in a magnetic field. So whenever there is a change in a magnetic flux will be existed, induced EMF is produced in a given coil, That what we studied in the case of the electromagnetic induction. But according to the Maxwell's equations, he didn't consider this equation. He considered what? About the induced electric field. So once the EMF will be there, automatically electric field is also existing. So that the third. Now, according to the Maxwell's third equation, he considered the equation that is line integral of E bar dot dl bar is equal to minus d phi by dt minus d phi by dt. Here, which type of flux he was considered means, he considered the change in a magnetic flux. He considered what? The change in a magnetic flux will be inducing the electric field. What he was considered means, according to the Maxwell's third equations, whenever there is a change in a magnetic flux will be there, which will be induces induced electric field. So this is the given by the Maxwell's third equations. The Maxwell's third equation is relating what? It is relating the induced electric field as well as the change in a magnetic flux. So that was given by the third Maxwell's equation. And the fourth Maxwell's equation is Ampere Maxwell equations. Already we studied in the moving charges and magnetism, we studied about the Ampere's law. What is the Ampere's law? The line integral of B bar dot dl bar is equal to mu naught into I net you studied. So what is the Ampere's law? Ampere's circuit law. According to the Ampere's circuit law, the line integral of the magnetic field over a given closed loop is equal to mu naught times the net current which is passing through the given closed loop. That was given by the scientist Ampere. But so whenever we consider the realistic situation, so Maxwell's proved that there is some uncertainty will be there, some term will be missing in the case of the Ampere's law. The missing term is nothing but displacement current. Actually, in the electromagnetic waves, displacement current topic was removed. What is the displacement current? How the displacement current will be existed means, whenever we applied an alternating EMF to the given capacitor, so through the circuit some current will be flowing, So whatever the current that is flowing through the given conducting wire, that current will be taken as conduction current. This conduction current will be existed due to the flow of the charges, due to the flow of electrical charges. Whenever you consider any one of the electrical circuit, generally we are saying that a current is flowing through the circuit. That a current is existed due to what? That a current is existed due to the flow of the electrical charges. But when we studied by considering the time varying electric field. So how the time varying electric field will be existed means, whenever the charge value will be depositing over the capacitor plates, the amount of the charge that was deposited over the capacitor plates will be changes continuously. Why? Here which type of source we consider? Alternating source we consider. So whenever you consider the alternating source, the amount of the charge which is stored over the capacitor plates will be changes continuously. So that a charge will be represented by Q of t, already we taken in the case of the alternating current. Whenever the charge deposited on the capacitor plates will be changes, potential is also changes with respect to the time. Potential is equal to what is the formula? Q by C. If a Q value will be changes with respect to the time, the potential difference is also changes. Whenever the potential difference is also changes, electric field is also changes. Since the electric field is equal to V by D, so if V changes, electric field is also changes. So when we consider the time varying electric field in between the capacitor plates, due to that, so the time varying of flux will be existed, the flux will be changes with respect to the time. So whenever you consider the change in electric flux, that a change in electric flux will be producing some of the electrical current. Such a current we are calling as a what? Displacement current. So that the formula for the displacement current is equal to epsilon naught into d phi E by dt. So in the Maxwell's equation, according to the Maxwell, which equation he was considered means, according to him, line integral of b bar dot dl bar is equal to mu naught IC plus mu naught epsilon naught d phi E by dt. So this is the fourth Maxwell's equation, what he was considered to explain the existence of the electromagnetic waves. Already I told how the electromagnetic waves are existed due to the combination of the time varying electric field as well as the time varying magnetic field. So here we will get the time varying electric field due to the flow of the charges, which is supplied by the alternating source of EMF. So that by this manner we will get the displacement current also. So that here two types of currents are there. One of the current is due to the conduction, and the another current is due to what? Displacement current. So that whatever the magnetic field you consider here, that a magnetic field will be existed, due to one of the electrical charges as well as due to the change in electric flux. Such a type of equation we are calling as Ampere's Maxwell's equations. This is a complete information about Maxwell's equation. And one more thing he considered to explain the electromagnetic waves, that is nothing but Lorentz force. Already we studied about the Lorentz force in the case of the moving charges and magnetism. What is the Lorentz force? Whenever we consider the moving charges, over the moving charges, due to the electric field as well as the magnetic field, simultaneously the forces are acting, so that the net force acting on the charged particle, due to the electric field as well as the magnetic field, such a type of force we are calling as a what? Lorentz force. So the equation for the Lorentz force will be given by Q into V bar plus V bar cross B bar. So this is the expression for the Lorentz force. So this is the complete information about the Maxwell's equations. Concept is our source of the electromagnetic waves. Already we told, so which type of fields are producing the electromagnetic waves means time varying electric field as well as the time varying magnetic field. So before going to discuss the time varying electric field as well as the time varying magnetic field, we are going to discuss about the stationary fields. So in the case of the electrostatics, we consider the stationary charged particles. If you consider the stationary charged particles, these stationary charged particles will be producing only the electric fields, Whenever you consider the stationary charged particles, these stationary charged particles are producing only electric field, and the nature of the electric field which is produced by the stationary charges will be remains constant. That means the electric field values, the electric field intensity values does not vary with respect to the time. So here, whatever the electric field we consider which is produced by the stationary charged particles, their magnitude value does not vary with respect to the time. Such a type of fields we are calling as stationary fields. Such a type of fields we are calling as what? Stationary fields. So what is the meaning of the stationary field? Means if any one of the field intensity or the magnitude does not be vary with respect to the time, such a type of fields we are calling as a what? Stationary field. So which is produced by the stationary charges. Suppose if you consider the moving charges, moving charges. So moving charges means what? Its speed value will be remains constant. So whenever you consider the moving charges, these moving charges will be producing both the electric field as well as the magnetic field. If you consider the moving charges, they will be producing both the fields, that is what? Both electric field as well as the magnetic field. Here also, whatever the electric field as well as the magnetic field you got, these fields are also not varies. These fields are also what? Not varies with respect to the time. So that whatever the electric field as well as the magnetic field you got from the moving charges, they are also what? Stationary fields. So from this we will get one clarity. What is that? What is the meaning of the stationary fields? Means if any one of the field will be independent of the time, so such a type of fields we are calling as a what? Stationary fields. So here both electric field as well as the magnetic field will be there, but these fields does not changes with respect to the time. So that these stationary fields, these stationary electric field as well as magnetic field does not producing the electromagnetic waves. The stationary fields, the stationary electric field as well as the magnetic field does not producing the electromagnetic waves. So for producing the EM waves, we need the time varying electric field as well as the time varying magnetic field, which is given by the accelerated charged particles only. So whenever you consider the accelerated charged particles, these accelerated charged particles will be producing the time varying electric field as well as the time varying magnetic field. Whenever you consider which type of charged particles? Accelerated charged particles. These accelerated charged particles are producing the both the time varying magnetic field as well as time varying electric field. So whenever these time varying electric field as well as time varying magnetic field are combined together, these will be producing the required electromagnetic waves. So what is the source of the electromagnetic waves? Means what? What is the source of the electromagnetic waves? That is nothing but accelerated charged particles. These are producing time varying electric field as well as a time varying magnetic field. Whenever they will be combined together, they will be producing the required electromagnetic waves. And the another source of the electromagnetic waves is nothing but oscillating charged particles. These oscillating charged particles are also one of the source of the electromagnetic waves. These oscillating charged particles, initially they will be producing the time varying electric field. This time varying electric field will be producing the time varying magnetic field. This time varying electric field is producing what? Time varying magnetic field. By combining the time varying electric field as well as the time varying magnetic field, they will be producing the required electromagnetic waves. So this is the source of the electromagnetic waves. Nature of the electromagnetic waves. Up to now what we told, so what is the source of the electromagnetic wave? Source of the electromagnetic waves. Already we told, what is the source of the electromagnetic waves? Either accelerated charged particles or oscillating charged particles. So what is the source of the electromagnetic waves? Means either accelerated charged particles or oscillating charged particles. So we studied in the case of the oscillations, if any one of the particle will be vibrating or oscillating, the displacement of the oscillating particle will be represented in the form of a either sine wave or cosine wave. So here also the source of the electromagnetic waves is a what? Oscillating charged particles. Already we told that these oscillating charged particles are producing the oscillating electric fields. So I am assuming that, so whatever the oscillating charged particles are, accelerated charged particle we consider, these charged particles are producing the time varying electric field, which is represented in the either sine function or cosine function. Why? Here the electromagnetic waves are propagating. In the form of a wave. So if any one of the wave we consider, that should be represented in the sinusoidal form. So here whatever the electric field that is produced by the oscillating charged particle will be represented by the equation E of t is equal to E naught into sine of kz minus omega t. So here I consider the oscillating charged particles. These oscillating charged particles are producing the oscillating electric field. That oscillating time varying electric field will be represented by the equation E of t is equal to what? E naught into sine of kz minus omega t. Whenever you consider the time varying electric field, it is also producing the time varying magnetic field with the same frequency. Why the frequency will be remain same means the source for both the electric field as well as the magnetic field will be remain only one, that is oscillating charged particle. With what frequency the oscillating charged particle will be oscillates, with the same frequency only the electric field as well as the magnetic field will be oscillates with respect to the time, so that the time varying electric field as well as the time varying magnetic field will be taken as E naught is E naught into sine of kz minus omega t as well as B naught into sine of kz minus omega t. Now these waves are combined together means, so whenever these two electric field as well as the magnetic fields are combined together, already we told that electromagnetic waves are formed. So here the direction of the propagation of the electromagnetic wave is always perpendicular to the direction of oscillation of the electric field and also perpendicular to the directions of the oscillations of the magnetic field. So here which type of fields we consider here? Oscillating electric field or time varying electric field as well as the time varying magnetic field. Whenever these time varying electric field as well as the time varying magnetic field are combined together, so which type of waves are produces? Electromagnetic wave will be produced. So whenever the electromagnetic wave is produced, it is propagating in a particular direction. So the direction of propagation of the electromagnetic wave is always perpendicular to the direction of the electric field as well as the direction of the magnetic field. And also we are saying that the direction of the propagation of the electromagnetic wave is always perpendicular to the direction of oscillations of the electric field as well as direction of the oscillations of the magnetic field. So the representation of the electromagnetic wave is like this. See here. So I am assuming that it is the x-axis, and this is a y-axis, and this is the z axis. X axis, y axis and z axis. I am assuming that the electric field will be oscillating along the x axis, or it is vibrating with respect to the x axis, so that the electric field vector will be represented by like this. So here the directions of the vibrations of the electric field will be perpendicular to the direction of the propagation of the electromagnetic wave. The electromagnetic wave will be traveling along the z axis. I consider the electric field vector along the x axis, so that its vibrations or oscillations will be perpendicular to the direction of the propagation of the electromagnetic wave. That only we told here. The direction of the propagation of the electromagnetic wave is always perpendicular to the electric field vector as well as the magnetic field vector. So here we assume the electric field vector will be taken along the x axis, which is perpendicular to the z axis. Now we consider the magnetic field vector. So this magnetic field vector will be represented along the y axis, and the EM wave will be traveling along the z axis, so that the time varying magnetic field will be represented along the y axis, which is perpendicular to the direction of the propagation of the electromagnetic wave. So this is a representation of the electromagnetic wave. So these vectors are representing what? Magnetic field. These are representing the electric field. So this is a representation of the electromagnetic wave. So now we are going to discuss about some of the quantities. So here we consider the time varying electric field will be taken as E of t is equal to E naught into sine of kz minus omega t, as well as the time varying magnetic field will be given by B of t is equal to B naught into sine of kz minus omega t. Let it be the equation number 1. So we consider two time varying electric field as well as the magnetic field vectors. Now here K is denoting what? So here K is denoting what? Propagation constant. K is denoting what? Propagation constant. Its the formula will be given by K is equal to 2 pi by lambda. K is equal to what? 2 pi by lambda. So that the propagation constant will be denoting what? Means the propagation constant will be giving the direction of the propagation of the electromagnetic wave. So that the propagation constant K will be giving what? It gives the direction of the propagation of the electromagnetic wave. So the physical quantity K is denoting what? The physical quantity K was denoting the direction of the propagation of the electromagnetic wave. Next, here we know that K is the propagation constant and omega is the angular frequency. Now we are going to define the second term. The ratio omega by K will be the constant. Which is giving the speed of the electromagnetic wave. If you consider the two physical quantities, one is omega, another one is a propagation constant, their ratio will be always a constant which is equivalent to the speed of the electromagnetic wave. Already we told the speed of the electromagnetic wave is nothing but the speed of the light in the vacuum. So that C naught will be taken as C naught. What is the C naught denotes here? Speed of the electromagnetic waves in the vacuum. C naught is equal to omega by K. C naught is equal to what? Omega by K. So this is the expression for speed of the electromagnetic wave. Speed of the electromagnetic wave. Speed of the electromagnetic wave can be written in terms of the permeability and the permittivity, so that C naught value also is equal to 1 by under root of mu naught epsilon naught. C naught, another formula, is equal to what here? If you consider mu naught, what is the mu naught? permeability of the field, that is representing the magnetic field, and epsilon naught will be denotes what? It is belongs to what? Electric field. Epsilon naught belongs to what? Electric field. Mu naught belongs to what? Magnetic field. So EM waves are the combination of the combination of the electric field as well as the magnetic field, so that the speed of the electromagnetic wave will be represented by 1 by under root of mu naught epsilon naught. If you consider the electromagnetic waves are traveling in the medium, its speed will be represented by C medium is equal to 1 by under root of mu into epsilon. So here whatever the mu naught comma epsilon naught will be considered, those are the values which are related to the vacuum. So whenever you consider the medium, the speed of the electromagnetic waves in the given medium will be given by C medium is equal to 1 by under root of mu into epsilon. Already we know that the relative permittivity is equal to mu by mu naught. From this we will write mu is equal to mu r into mu naught. Similarly, the relative permittivity is equal to epsilon by epsilon naught. From this we will write epsilon is equal to epsilon r into epsilon naught. So already we know the formula for the relative permeability, what we studied in the magnetism. Relative permeability is equal to permeability of the medium by permeability of the vacuum. From that I taken the value of mu. Similarly, the relative permittivity is equal to permittivity of the medium by permittivity of the free space. So mu is equal to epsilon r into epsilon naught. If you substitute these values in the above equation, you will get C medium is equal to 1 by under root of. In the place of mu, what we have to write? Mu r into mu naught. So here I will write mu r, here I will write mu naught. Next, in the place of the epsilon, we have to write epsilon r into epsilon naught. Here I will write epsilon r, here I will write epsilon naught. So once again, if you simplify this equation, C medium is equal to 1 by under root of mu r into epsilon r, 1 by under root of mu naught into epsilon naught, mu naught into epsilon naught. If you see here, C naught is equal to what you got? 1 by under root of mu naught epsilon naught. Here also, in the place of 1 by under root of mu naught epsilon naught, we will write C naught or C vacuum. So therefore, C medium is equal to C naught by under root of mu r into epsilon r, mu r into epsilon r. Therefore we will write C naught by C medium is equal to C naught by C medium is equal to under root of mu r into epsilon r, under root of mu r into epsilon r. Term within under root of mu r into epsilon r will be equivalent to what? Will be equivalent to refractive index of the given medium. Refractive index of the given medium. Therefore, refractive index of the given medium is equal to under root of mu r into epsilon r, or refractive index is equal to C naught by C medium. Refractive index of mu is equal to what? C naught by C medium. C naught is indicating the speed of the light in the vacuum. C medium is indicating what? Speed of the light in the given medium. So this is about the concept of nature of the electromagnetic wave. The remaining topic we will discuss in the next class. Thank you.